this, that, or the other. Canvas lets you do that. So that's why I use both the Canvas gradebook and the Skyward gradebook. It just makes things easier sometimes for things. So the quiz is in, the grade's in. By the end of the chapter, you'll get to have it back, but I have to wait for kind of everybody to take it before I can give them back to you. If you want to look at it when we get to some work time today, which we should have a little bit, you guys can look at it, but you just can't keep it until everybody's taken it. So we have that. But after a quiz, if we have something where I've seen several people make the same mistake, we will talk about them real quick. And so if you see something that you did come up in a, day or two after a quiz, first page, that doesn't mean I'm calling you out. It means it happened repeatedly with multiple people, which is why this doesn't have examples of somebody doing it. Okay, so we're going to talk through some mistakes that I saw repeatedly, and I saw these on several different quizzes. So we're going to talk them through, and then we'll get to what we need to. Okay? Okay. So after this first quiz, I had several people do some weird things with negative exponents. When we have a negative exponent and we're trying to make it flip into the reciprocal, it just takes that guy. He's the only one affected. This is the same thing as if I wrote x squared times 1 over y squared. It does not change where the x is. The x is still a positive exponent. So this is the exact same thing as if I had x squared over y squared. The negative exponent doesn't take everybody nearby. It just takes the guy with the negative. Okay? So just be careful with that. I had a lot of people switching lots of things with negative exponents. There was all kinds of interesting choices. So just be careful with those, because this is what it should be. Another thing I saw a lot of times was when we had powers over powers, particularly when there was a coefficient, we would just skip the coefficient. So when we have things being raised to a power, this needs to be 4 to the 3/2 and our x to the 4th to the 3/2. Both of them get that exponent. They both do. So when we're dealing with that, then we can deal with that in several ways as we move forward from there. We can deal with our powers over powers as multiplication, or you can deal with it as roots in an index or roots in a power. Either way is fine. I do think there's sometimes it's going to be easier to deal with this as our index of 2, where we're taking our 4, we're doing our square root, and then cubing. That's the same thing. What is the square root of 4? What's 2 cubed? Okay. Because this is the same thing as if it said 2 cubed square root of 4. Okay, so you can absolutely do it that way. We can look at our x to the 4th to the 3/2, and you can 100% do it that way. You can set it up with square root of x to the 4th and then cube it. Or with this variable piece, we can take our x to the powers over powers, and we're going to multiply our 4 times 3/2. What is 4 times 3/2? 6. So we're going to wind up with x to the 6th. Because you can either do 4 times 3 gives us 12. 12 divided by 2. You can do 4 and 2 simplify to get 2 times 3. However you want to do it. You can do the variables the way you did the numbers. You can do the numbers the way you did the variables. All kinds of options. There's not one necessarily path to solve it. There's lots of options through it, but the constant needs to get the power as well. I had a lot of people that would just skip the constant. And then I think because it was after our domain restriction absolute values, we had some bold choices on our numerical absolute values. So when we're simplifying these, treat your absolute values like they're parentheses. Simplify inside first and then do your absolute value. Because we need to do our absolute value of negative 3. Yeah, we can do that, but we need to simplify 10 minus 12 first. What is 10 minus 12? negative 2. So this is really saying absolute value of negative 3 plus absolute value of negative 2. What is the absolute value of negative 3? 3. What's the absolute value of negative 2? 2. What's 3 plus 2? Okay, I think it was just because it was right after the absolute values that were the weird worded things that we just got all kinds of tangled up in our own brain. Because it had the main restriction pieces. So whenever we have just numbers, order of operations, don't overthink it. We just got caught in our own brains on that one. Okay, so just be careful. Questions on any of these three? Okay, because we are going to look at our rational functions some more, our rational expressions. We're going to keep going in section 1.4 here. And what we're going to look at today is we're going to think about doing some products and quotients. So since we're going to be looking at rational functions to do products and quotients, let's take a second and remember how to do fractions with products and quotients, because that's a big part of it. So we're going to keep working in 1.4 today. So, products and quotients of fractions. So when we have something like 5/7 times 3/4, how do we multiply fractions like this? Across. We go straight across. 5 times 3 gives us 15. 7 times 4, 28. We multiply straight across, and then we have to check and see if they simplify. Or we can simplify in the multiplying step. We'll look at that in a second. When we did division with fractions, we had a little phrase that we remembered. What do? Keep, change, flip. We keep the first fraction, we change the sign between them, and then we flip this. It's keep, change, flip, or it's multiply by the reciprocal, if we didn't hear that phrase before. So our first fraction stays the same. We're going to have our 5/7. That's what we mean by keep. We change the sign from division to multiplication, and then we flip the second fraction. So instead of my 7 being in my denominator, it's going to be my numerator. And then we have our 2 as our denominator. So we flip it, we make it be a reciprocal. And then we can multiply it exactly the way we did for the first one. I can multiply straight across 5 times 7 to get 35. And we can multiply our denominator, 7 times 2, to get 14. Then we would need to simplify. That is absolutely a valid way to go this way and simplify it to get our answer. But there is an easier way than multiplying together to then simplify. Does anyone spot what we could simplify in the multiplication step? We can cancel out the 7s. So because I have 1 on the top and I have 1 on the bottom, I can cancel those guys out. So a lot of the times we are not going to fully multiply things together before we come through to cancel. It's going to leave us with just our 5 times 1, because 7 over 7 is 1. And 1 times 2, giving us 2. If we were to simplify 35 over 14, because both of those are divisible by 7, we would wind up exactly at 5 over 2. So you'll get to the same place. You just won't have to do so much simplifying of the fraction if we stop in the multiplication step to try and simplify here and then go down to the multiplication step. Okay? So we're going to be working with our rational expressions, these fractioning things that look awfully polynomial. I wonder what we're going to do with them. All right, we're going to start with some smaller ones. So we're going to do products and quotients of our rational expressions. And I'm going to zoom in on each one of these just because I know sometimes they're a lot. So our first one we're going to look at is 9y squared over 8 times 32x over 27y. And we could just come through here and go straight across and multiply straight across in our numerator and straight across in our denominator. But 9 times 32 is going to be a big number, and I don't know it off the top of my head. 8 times 27, same thing. I don't want to. Ew. So let's see if we can do some simplifying here. Do we have anything in here that can simplify? The 9 and the 27, because 9 goes into 27 how many times? 3 times. Anything else that we can simplify? The 8 and 32. How many times does 8 go into 32? 4 times. Anything else we can simplify here? The y's. I have a y squared and I have a y. So I have 2 y's up here and I have 1 y down here. So this is going to cancel out with one of the y's. So whenever I'm changing an x, if I have a y squared, I will just change my exponent from a 2 to a 1. But you can do it whatever way you want. If you're working on this and you ever want to have colors, people color code like I do, because my green piece cancels out with the green piece, purple cancels with purple, pink with pink. I have a gabillion colored pencils, markers, highlighters, whatever. I can get them out easy peasy. They're in little like in shoe boxes. Totally fine. I can get them out if you ever need them. When you get to this point, if you're doing cancel out stuff and you go, it's getting very crossy-outy, I can't tell what's left. Rewrite it and then take a look at it. So once we get here and we go, well, it's getting really crossy-outy. So let's write down what we have left. In my numerator, I have y times 4 times x. Those are the pieces we have left in the top. So if you want to put y 4x, I'm okay with that. Best grammar has the number in the front, then xy. But y 4x, yx 4 works. It's just like Yoda. It's not, I am fine, it's fine, I am. So it's not wrong, it's just weird. In our denominator, the only piece we have left is the 3. So that whole thing simplifies down to be 4xy over 3. It does not simplify any further. Okay? Questions on that one? Okay. We're going to do another one. It's a little bit more complicated. And I've got both of them up here for a second because what we have over here, we had monomials. We just had single pieces. And we could go straight into canceling things out because everything is being multiplied together. Whenever we have expressions like this where we have pluses or minuses in them, I can't just go straight into canceling out. I cannot come through here and say, ooh, look, x squared over x squared and cancel it out. Don't do that. We can't do that. We have to have things being multiplied first. So when we're looking at this one, the first thing we need to do is we need to get this into factored form. So we cannot just hop through and start trying to simplify. We've got to factor it first. We cannot start crossing things out if it's in our standard form. We've got to have it in factored form. So I'm going to give you guys a second to write it down. We've got our 2 fractions here. Our left fraction has x squared minus 16 in the numerator and x squared in the denominator. And we're multiplying that with one that has x squared minus 4x in the numerator and x squared minus x minus 12 in the denominator. So when we're looking at this, the first thing we need to do is get this into factored form for all these pieces. So I'm going to put my 2 sets of fractions here. If I want to factor x squared minus 16, how can I do that? It's a difference of squares. I was like, I heard somebody say difference of squares. I heard someone else just starting with factors. Totally valid. We know that x times x gives me x squared. So we're going to have an x in each of these boxes. What squared makes 16? 4. So we're going to have an x plus 4 and an x minus 4. One piece gets a plus, one piece gets a minus. If I multiply that back out, I want 100%. I'll get my x squared minus 16. Same thing. My denominator here is my x squared. That's, if you want to write it as x times x, you totally can, but it's not really any different than just having an x here. Looking at our numerator over here, x squared minus 4x. What can I do to try and factor that thing? Take out an x. It's got a greatest common factor. It's got a GCF of x. When I take an x out, we're left with x minus 4. So we've had a GCF. We've had a difference of squares. Our denominator over here on this side is a regular factoring, I guess, in check. I'll split the middle, x in box, however you like to do it. I tend to do a combination of the shortcut mode and my x frame. We have my a times c, which is negative 12, and my b is minus 1. Sideways 1, we don't know why it's well. There we go. What pair of numbers do we know that's going to multiply to make negative 12 and add to make negative 1? Negative 4, positive 3. So my factored form is my x minus 4 and my x plus 3. So we've got to get it in factored form first. Now we can look through this and try and do some simplifying. Questions on any of the factoring before I go to the simplifying part? Cool. What do we have that's going to cancel out? An x minus 4. So this x minus 4 in the denominator is going to cancel out with 1 x minus 4 on the top. Either this guy or this guy. Not both. Just one. I'm just going to take that guy because he's right there. It does not matter which one. What else do we have that's going to cancel out? An x. This x is going to cancel out with one of my x's right here. Do we have anything else that's going to cancel out? No. So then we're going to come through and we're going to do our multiplication. Things on the top times things on the top. Things on the bottom times things on the bottom. So the stuff we have left on the top is just these two guys over here. We're going to have our x plus 4 and our x minus 4. They're hanging out. And in our denominator, we have just one x and our x plus 3. We do not need to multiply these back out. I recommend you don't. It's just giving yourself extra work for no benefit. This is the easiest way to write our answer. That's going to be how we do that. There we go. So when we get to the point that we do need to multiply out our numerator, I will let you know. Our denominator, we're pretty much just going to leave in factored form. Unless we specifically tell you not to. Just leave the denominator there. You do not need to multiply it back out. You're just making extra work. Okay? Leave it as factors. Questions on either one of these two? Because we're going to look at a couple more. And I want you to take a breath before we look at these ones. I'm going to zoom them in, so we're looking at one at a time. Don't panic. We're going to look at this one first. I was trying to be fast, so we didn't look at the one that looks super scary. So we've got two fractions here. We've got a squared minus 6a plus 9 over a minus 3. And then we are asked to divide that by the fraction that has a minus 3 as a quantity squared over a squared plus 3a minus 18. So there's a lot of pieces here. And I definitely see that we have adding and subtracting, so we know we're going to need to do some factoring stuff. We also see this division in here, so we're going to need to pay attention to the keep, change, flip stuff. So when we have stuff that's quite this complicated, I tend to do my factoring and my keep, change, flip in the same step because, ew, I do not want to have to write it twice. Gross. I'm lazy. If you want to write it first, where we do our keep, change, flip, and then factor, totally valid. If you want to factor and then do your keep, change, flip, totally valid. I just tend to do them both at the same time because, again, I don't want to write it that many times. It's a lot of stuff. So we know we're going to need to pay attention to our keep, change, flip. But that means my first fraction doesn't really change all that much. So we're going to have our a squared minus 6a plus 9 that we need to put into factored form. What is that one going to be in factored form? multiplies to be 9, adds to be negative 6. Negative 3 and negative 3. So this is going to be our a minus 3 times a minus 3. Because minus 3 and minus 3 multiply to make our positive 9, add to make our negative 6. Our denominator isn't really changing. That a minus 3 is just going to hang. I'm just going to put it in a set of parentheses so we remember that's one chunk. I can definitely add parentheses here if that helps me. Like, totally thing we can do. Then we need to remember that we are going to change our sign. And that means our second fraction we need to flip. So what was in my numerator is going to become my denominator. We're going to have our a minus 3 squared. If you want to write that out as a minus 3 times a minus 3, that is 100% valid. If you want to put that as a minus 3 squared, also 100% valid. Totally fine. Either way is fine. Then we need to look at our denominator here, and we need to factor this guy. And again, I'm going to do our little x box, or a little piece of the x. We need a pair of numbers. It multiplies to be negative 18 and adds to be 3. 6 and negative 3. So it was in our denominator, so now it's in our numerator after we're doing this flip. So we're going to have our a with the positive 6 and our a with the minus 3. So we did all of our factoring and our keep, change, flip in one step. Again, if you want to do that in 2 separate steps, totally fine. I really don't like to write all of that all over again. So I try and do them all in just one step. Okay? Because now that we have this as multiplication and everybody's in factor form, we can come through here to try and simplify. What do we have in here that's going to simplify? A minus 3. And we have a bunch of them that are going to cancel out. Because I get one that's going to cancel out here. I have another set that's going to cancel out. This guy's going to cancel out with one of my exponents up here. And then we also have this a minus 3 that's going to cancel out the other one that's down here. So I had 3 a minus 3s on the top, and I had 3 a minus 3s on the bottom, so they all canceled out. So this whole thing, this whole fraction on a fraction thing simplifies down to just be a plus 6. This is a very, very complicated way of writing a plus 6. It means the same thing. They are equivalent. They are gross, but they are equivalent. Okay. Questions on that one? I'm going to put up the next one, and I'm going to say, don't panic. I'll give you guys a second to write, because I have a lot of pieces. Our left fraction, we have our numerator of 4x squared minus 9y squared, and a denominator of 8x cubed minus 27y cubed. And then we're dividing by a fraction that has our 2x plus 3y as a quantity squared, and a hot mess of a denominator that's 4x squared plus 6xy plus 9y squared. Gross. So let's look at this and see what we can do. First things first, let's see if we can do on the left side to see how that's going to factor. What can we do with 4x squared minus 9y squared? It's a difference of squares. 4x squared is a perfect square. 9y squared is a perfect square. This is a difference of squares. So we can go straight into our pattern here because we know what gets squared to make 4x squared. 2x. So we have 2x in the front 2x times 2x gives me 4x squared. What squared gives me 9y squared? 3y. Good. 3y and 3y. One pair gets a plus between them, one pair gets a minus between them. Difference of squares pattern. It's an important piece to know. If you want to do it by hand, you totally can, but it's two variables, and that is gross. So yeah, a pair of numbers that multiplies to make 36 and adds to make 0. Then you have to factor. And then it's a mess, but it's doable. Then let's look at our denominator here. What do we notice here? Difference of cubes. So this is the same thing as if I had not 4x squared, but 8x cubed. It comes from our 2x being cubed. And 27y cubed comes from what being cubed? 3y. Oh, familiar pieces. Oh my gosh, what? So when we're following this pattern here, which we are going to need to know, that was our SOAP. Remember that. So we have our first term, that 2x. Using our same signs, we're going to have a minus our 3y. Then we're going to have our first term squared. So my 2x as a quantity squared, giving us 4x squared. Then we use our opposite signs. We're going to have a plus. This piece, my front piece, times the back piece. 2x times 3y. Giving us 2 times 3, which is 6xy. Getting that once. And then we always have a plus at the end, always positive. Our 3y, that's being squared. So 3y times 3y gives us 9y squared. That difference of cubes or sum of cubes that we use SOAP for is a pattern we need to know. We need to get that. So make sure we practice with that with bunches. Just making my fraction a little bit longer. So our first fraction we kept exactly the way we had it. Since we're being asked to divide, I'm going to do my keep change flip here. So my numerator that we had up here, which is already in factored form, I'm just going to write in my denominator as our 2x plus 3y as a quantity squared. And that denominator, we go, ew, gross. Does that look like something we can factor? I don't have to factor. It's got 2 letters in it. Does it look really, really familiar, though? Our 4x squared, 6xy, 9y squared. Oh my gosh, it's this guy. So I'm just going to take him, and I'm going to put him in parentheses here. Our 4x squared plus 6xy plus 9y squared. All is one chunk. I'll say again, you could try and factor it. It's not going to factor, but you could try. It's just gross. But it's a really familiar piece, and what do we know is notice is going to happen between the gross pieces? They're going to cancel out, thank gosh. Oh my gosh. Because this guy is super duper extra gross, but so is this guy. And they're the exact same thing, so they cancel out. What else are we going to have that cancels out? 2x plus 3y. I've got one of these guys canceling out with one of those guys, because I had 2 of them down there. And we have a 2x minus 3y that's going to cancel out. That's going to be this guy and this guy. What are we left with in our numerator? 1. Think of it like 7 over 7 or 2 over 2. If it's exactly the same, it's not that we have 0 up there. It's not that we have nothing. It's just 1. It's simplified down to be 1. And our denominator, the only thing I have left down there is 2x plus 3y. Whether you put that with parentheses or without, I do not care. If we are down to a single factor, it does not matter. This is 100% the exact same thing if it has parentheses in it. Totally fair. If we have more than one piece, so if I had two factors like we had over here, then we need to keep our parentheses in there. Otherwise, you have to multiply them out properly, and there's no point in doing that, so don't do that. So when you have just one factor, you can choose if you have your parentheses or not. It genuinely does not matter even a little bit. Whatever way makes your brain hurt less. Because I know they're not always the most pleasant. But that's our answer. Okay? Questions on these ones? Okay, so multiplying and dividing, we know what to do. Tomorrow, what we're going to talk about, because we're not going to start it right now, we're going to do some adding and subtracting. Oh my gosh, what? So what we're going to do now is we're going to have some time to work, just because I know we've had a lot of stuff, but I want us to have some time. So homework 1-4, I have up here, I've crossed out 56, 58. Don't do those. Cross them out. I don't like them. I don't want to do them. There's no point in doing them. Don't do them. The other ones should be fine. So 1-4 is listed as due Wednesday. Tomorrow we're going to talk about the adding and subtracting. We're going to do quiz 2, which is over sections 1-3 and 1-4. That's going to be on Thursday. We will have quizzes or some sort of assessment most weeks. If we have a test that week, we won't have a quiz that week because I'm not that mean. Most of the time. There shouldn't be. So, like I said, quiz 1 is in. When it's, when we start looking at grades for things like that, as we get closer to the end of the semester, I will remind you guys, your lowest quiz score for the whole semester will just drop. So the lowest quiz will drop. And then as a reminder, your lowest test grade, if it is lower than your final exam, will get replaced with your final exam. So I know for some of us, we were not super pleased with our quiz 1 grade. Part of that is because we're just kind of learning how things are worded, or we made some silly mistakes, and that's okay. We're still learning, getting the feel of it. The lowest quiz score will drop. So for some of us, it's going to be quiz 1. So for some of us, it might not be, and that's okay. I want that. So we have time right now. So if you have questions on homework 1-3 or homework 1-4, we have about 10 minutes where you guys can look at that. You can work on stuff. You can ask questions. We can work through them together on the board if you want, or you can work on your own. Okay? So take a look at 1-3. Get started on 1-4. Tomorrow we're going to finish it up, and we're going to deal with adding and subtracting these rational expressions. Okay? That's 1.4.